हालोअरीन आसानी से काबू में नहीं आते हैं। देखो हालोअल्केन की प्रॉपर्टीज बड़ी आसान होती है कि R और X के बीच का जो बॉन्ड होता है ना बड़ा पोलर होता है। C होता है sp3 हाइब्रिडाइज, तो बड़ा आसानी से टूट जाता है। यहाँ पर मुश्किल क्या आ रही है, जो कार्बन है ना वो sp2 हाइब्रिडाइज्ड है, ठीक है। कौन सा वाला कार्बन? बेंजीन का कार्बन। सो क्लोरीन के साथ पंगा करता है। क्या पंगा करता है? क्लोरीन के इलेक्ट्रॉन आ जाते हैं रेजोनेंस में, बीच में आ जाता है डबल बॉन्ड। जैसे डबल बॉन्ड आता है हमारा काम बड़ा खराब हो जाता है। क्या खराब होता है? C और Cl को तोड़ना नामुमकिन हो जाता है। कोई बात नहीं, CCl नहीं टूट सकता है, बाकी रिएक्शन करने की कोशिश करेंगे। बेंजीन रिंग है, क्लास 11th में हमने पढ़ा था। बेंजीन रिंग होती है तो क्या करती है? हेलोजिनेशन, सल्फोनेशन, नाइट्रेशन, फ्रीडल क्राफ्ट। तो किसने कह दिया कि जब क्लोरीन लगेगा तो ये नहीं होगा? ये भी होगा, बिल्कुल होगा। एक और कॉन्सेप्ट पढ़ा था, डायरेक्टिव इन्फ्लुएंस ऑफ इनकमिंग ग्रुप। तो ठीक है, Cl अपना टीचर बन गया बेंजीन के ऊपर। टीचर किसको गाइड करेगा? जो इलेक्ट्रोफाइल आएगा उसको गाइड करेगा। क्या बताएगा कि जो इनकमिंग ग्रुप है वो कहाँ जाएगा, ठीक है। तो आपने जब हेलोजिनेशन किया, आपने फ्रीडल क्राफ्ट किया, आपने सल्फोनेशन किया, नाइट्रेशन किया, तो जो भी आपका नया इलेक्ट्रोफाइल है अपन उसको E+ मान लेते हैं। तो वो E+ कहाँ जाएगा? वो E+ ऑर्थो और पैरा पे जाएगा। क्यों? क्योंकि ClOP डायरेक्टिंग है, ठीक है। तो इस तरह की एक रिएक्शंस हो जाएंगे। अब जल्दी से स्क्रीन के ऊपर चलते हैं और थोड़ी सी और रिएक्शंस करते हैं। ओवर टू द स्क्रीन। Studied under 3 heads. Nucleophilic substitution reaction means that we need to break this X, right? It is difficult to break this X because there is resonance. There is resonance. Due to resonance, carbon and X will have a double bond character. That is another difficulty. And if X is completely broken off, the phenyl carbocation which you get is not resonance stabilized. And the fourth reason is the nucleophile, it gets repelled by 3 pi bonds. So because of these reasons, nucleophilic substitution is not that easy. However, if we take a very high temperature as 623 Kelvin and a very high pressure of 300 atmosphere, what happens is OH being a very strong nucleophile, and this, I'm telling you guys, this reaction doesn't happen very often. If instead of chlorobenzene you have phenol, benzaldehyde, aniline, anything, the reaction is very difficult to take place. So now what happens? First you get sodium phenoxide, which on acidification will give you phenol, right? So this is a substitution reaction that takes place under very, very drastic situations. You have seen the temperature and pressure. And one thing I just want to tell you, that these conditions will become milder and milder if we have one electron withdrawing group at NO2. What happens? Instead of 623, you will need 443 Kelvin. Instead of concentrated alkali, you can take 50% of alkali. And if you take NO2 at ortho and para, reactions further is facilitated. Why reaction becomes easy? Because NO2 is electron withdrawing group and it facilitates the removal of Cl, right? As nucleophile attacks, right? If the nucleophile attacks here, what will happen? You will have the next diagram as this is your Cl and there will be a negative charge here. Rest all remains same. And NO2, what will NO2 do? NO2 is an electron withdrawing group. So it will try and absorb the charge. So the moment this negative charge came, and where this negative charge is going to go? At ortho and para, and at ortho and para if we are putting NO2, the reaction will become much, much easier. NO2 here, NO2 here, reaction will take place almost at room temperature. So it will take place with water at 323 Kelvin, which is not even room temperature, and what you get the substituted product. That is the beauty of putting electron withdrawing group at the positions where resonance charge is located. Let's move on to the second type of substitution reaction under halogenation, nitration, sulfonation, friedel alkylation, acylation. Same is going to happen here also. But since Cl has minus I effect, since Cl has minus I effect other than plus R effect, right? So due to plus R, reaction will take place at ortho and para, the substitution will be at ortho and para, and due to minus I effect, the reaction will be slow and the conditions will be more drastic. So wherever you see, you are going to see a content of heat. Since it's a substitution reaction, first we will have chlorobenzene, all will have Cl, and with the Cl there is going to be further substitution. Now where the substitution will take place, I think now you can make out. So in first case the substitution will take place at ortho, you get 1 Cl, at para you get 1 Cl, and plus you get HCl as byproduct. In the second one it is nitration, so you get nitro at the ortho and nitro at the para. In the third one it is sulfonation. Again you can see conc H2SO4 with heat is there, so reactions are going to be drastic, so you get SO3H at the para, SO3H at the ortho, but it is going to be a very, very small amount. It is going to be minor at ortho. Minor at ortho, why? Because of steric factors, right? And this reaction is Friedel-Crafts. This is your Friedel-Crafts reaction. So you will have CH3 at ortho and CH3 at para. And in the last you will have COCH3 at para and COCH3 at ortho positions, right? So with this, it is simple. Benzene, in benzene you were having electrophilic substitution which were faster. In chlorobenzene is going to be slower, and the substitution will be at ortho and para. I think I did miss out the byproducts. You know, in nitration always water is the byproduct. In sulfonation also water is the byproduct. In Friedel-Crafts it is going to be Cl coming out, so we will have HCl, and here also we will have HCl as byproduct. Reaction with metal. So we have two types of reactions. If we take only haloarene reacting with itself, so that is known as Fittig's reaction, and you get diphenyl as the product, or you can call it phenylbenzene as the product. This is phenylbenzene will be the product. But if you take alkyl halide, so we call it Wirtz because of the alkyl part and Fittig because of the aryl part. And most importantly, you get alkyl substituted benzene, but you can expect the small amount of reaction where both these products they react with itself. That is haloarene and RX, they react with itself to give RR and biphenyl also. One more reaction of haloarenes. Instead of sodium we take metal magnesium. They form phenyl magnesium halide Grignard reagent. Here it has carbon and metal compound. It has carbon and metal bond, so we can call it organometallic compound. Call it organometallic compound. That's all about the reactions of haloarenes. So I hope chemical properties में मज़ा तो आया ही होगा आपको. बहुत मज़ा आता है जब हम बेंजीन बनाते जाते हैं और जल्दी से सब्स्टिट्यूट करते हैं, और क्लास 11 का सारा याद आता रहता है ना. आई होप आपको भी याद आएगा, और अगर नहीं याद आया ना तो इट्स रियली बैड. क्लास 11 के वीडियोज़ जरा आप देख लो. ठीक, सी यू इन द नेक्स्ट क्लास. टेक केयर ऑफ योरसेल्व्स. गॉड ब्लेस. बाय बाय.